Now, horizontal asymptotes. A horizontal asymptote is a horizontal line that the graph of the function approaches indefinitely. And for it to happen in the horizontal, that has to be when x goes to plus infinity or x goes to minus infinity. There's no other option if you think about it. The y, let's say y equals L. This is a horizontal line at the height of L and the y-axis. So this is L. And for the graph of a function to approach that indefinitely, it needs to be going to the right like that, right? It needs to be going either to the right or to the left. So the graph could approach from the top too. And it could happen on both sides or just on one of the sides, meaning only one of those limits is enough. But we never know which one it will be, so we always check both. We never know for sure if both are going to be the same. And this limit needs to be a real number too. L can't be plus or minus infinity because that would imply that the function is just going up forever. And that's not an asymptote, horizontal asymptote, right? That's just going to cross that horizontal line regardless of its height. So let's see what happens as an example. For f of x equals e to the x, we know the graph of this guy. We know it's going to look kind of like this. And we can see analytically or using other tools that the limit x goes to plus infinity of e to the x, that's plus infinity 2. Right? Just think about it. The bigger the power, you're multiplying e by itself over and over and over again. Right? E is a number that's bigger than 2, so e times e times e times e is getting bigger and bigger and bigger, so the result will be plus infinity. So there's no horizontal asymptote on that side, which kind of makes sense because we know the graph. If you look at the left side, e to the x, what you have is, you can think about it that way, e to minus something big, that's e, so 1 over e to something big. So that means the bottom is really, really big. That's 1 over something big. So that's just something very small. And as an observation, e to any power is going to be positive, right? Because you're multiplying e by itself, so that's positive, which means this is also positive. But it doesn't matter. What matters is that the limit when x goes to minus infinity of e to the x equals to 0. So y equal to 0 is the only horizontal asymptote, which again agrees with what we know about the graph. Right? This line y equals to 0 lives right here. This is, I'll maybe use a different color just to illustrate it. So y equals to 0 is this horizontal line, is the x-axis. And this line is clearly an asymptote because the graph of e to the x approaches this green line when it goes to the left like this. So let's go G. All we need to do then is calculate these two limits, basically. Right? As soon as we find one, that's one asymptote, we go ahead and calculate the other one. Contrast that with how we find vertical asymptotes. Vertical asymptote, we first need to find the a values, the candidates, right? And then as soon as we test one side for that candidate, we can go to the next candidate. Here for horizontal asymptotes, we just have two candidates, just plus infinity and minus infinity. We just test them both and see. And there's no left or right side for plus or minus infinity because plus and minus infinity are not numbers, so there's no left side of one and there's no right side of the other. Let's go with this thought, let's go to G. So what's the limit of g of x when x goes to plus infinity? That will be limit. Remember that thought process we used before? X is getting very, very, very big. So let's say x is 1,000,000. Let's say x is 1,000, right? right? Let's say x is 1,000. Then x squared is about 1,000,000, right? 3x squared is 3,000,000. This is 3,000. Even though this is big, this is not nearly big enough to compare to 1,000,000, to 3,000,000. Right? So all that matters is this leading highest degree coefficient, same for the bottom. So this is the limit of 3x squared over 3x squared. Sorry, the bottom is 2, right? 2x squared. Cancel these two. That will be a limit of 3/2, which is just 3/2. Doesn't matter what x is going to. The limit of a constant is just a constant. So this is y equals 3/2 is a horizontal asymptote. We got to check to see if there's another one on the left side. So we're going to do the limit when x goes to minus infinity. Maybe I can kind of itemize these so it's easier to read. So I do the same thing. X is still getting big, so it doesn't matter what happened before with the millions and the thousands still happens now. And still same thing, it cancels, so this is 3/2. We don't get another asymptote, we just get another fact about the graph. So there's only one asymptote because y equals 3/2 is it. But if you graph it, 3/2 is kind of here. What we know is that the graph is approaching this line on the right as well as on the left. And again, we don't even know if it's here or if it's here, right? Don't even know that. I just know that as x becomes very big to either side, that the y value becomes very, very close to 3/2. And then the middle, like the middle could be anything, I don't know. It could even cross the line again, I don't know. As long as it's a function, it stays a function. The middle could be anything. I'm not sure what it is in the middle. All I'm sure about is this behavior here. And even so, like I'm only half sure because I don't know if it goes up or down. I could check. Leave the check for another time. What happens on C? The limit x goes to plus infinity of g of x. Same thing. Look at the leading coefficients. One is x squared, the other x cubed. 3x squared, 2x cubed. Cancel the square with the cube. 3 over 2x. This is, the bottom is getting super, super big. So this is getting very, very small. If I do the limit, x goes to minus infinity of g of x, I do the same calculation. It's 3 over 2x. Now x is getting very, very negative, very big, but negative, so the answer is still getting very, very small, so it's still 0. The bottom is still super big. The difference is that this is going to approach 0 from the left, from negative values, right? This is going to be always negative, and this is going to be always positive. So basically, the one horizontal asymptote we have is this. And noting what I just noted about the values being negative or positive, if you look at the y equals 0 line, which is just the x-axis, right? You have that the graph of this, when x goes to the right, these are positive, so we're approaching from the top. Now we know for sure that it's over and not under. And on the other side, it's like this. Now our last one is the easiest one. Limit of h of x when x goes to plus infinity. We're going to do the limit when x goes to plus infinity of cosine x. We know what the graph of this thing is, so it does not exist because cosine oscillates non-stop between minus 1, 1, minus 1, 1, minus 1, 1. There's no one value that this number approaches, that the cosine approaches. Right? There's no one number that it approaches. So we can conclude that the same will happen on the left side. It also does not exist. And this means that there are no horizontal asymptotes. Hope this was helpful. This is what I had to say.